All right. Hey, everybody. All right, last session of the day. Hope everybody's had a great time out here in Las Vegas. I don't know if anybody's had a chance to go out and gamble or do any of that. I actually went and did a poker tournament. Not a really big poker player, but I finished 12th at the tournament. So, yeah, thank you. Fortunately, there was only 12 people in the tournament. So, but I was happy with that outcome. So. Today we're going to talk about Capital One, and so my name is Ryan Thurston. I'm with AWS, Principal Go-to-Market Specialist. I'm joined by with Geeta and Preston, who are going to jump on here in a bit. And my role is really fun at AWS. I get to go out and talk to customers just like you and talk about our services. And also part of my job is communicating back to the product service teams about our services and how we can improve our products. So. Really excited to talk through some of this today. I'll be on stage for just a little bit here, and then we'll bring up Geeta and Preston. But one of the parts of my job that I really enjoy is the strategic vision. And so when I talk to customers in my role, we get to talk about what does the next few years out in the industry look like. And so due to the pandemic, we've seen a lot of changes in the industry, and you've probably noticed these yourself. Anything from retail and how a lot of the sales are going online, financial services, banks are closing down, physical locations. Insurance is another big one that's being upended. I had a buddy that was actually just in a car accident, and when the adjuster came, he didn't have to do anything with an adjuster. He downloaded the app. He was able to take pictures of the accident. He was able to fill out the forms. Very different from 20 years ago when I got into my car accident when the insurance adjuster had to come out. I had to fill out the paper forms. We had to, take the photos, take the time to get them developed. So very different experience. And then mobile especially, this is a big one. I was really surprised when I checked into my hotel this time. I actually took advantage of the mobile key. I had never done this before, but I arrived here, late at night on Sunday, just really tired, wanting to get into my room. And I walked by the check-in line, and I saw the lines. There's probably at least 30, 45-minute wait. But I was able to just go to my room, open up the app, and get into my room very quickly. So that was really exciting. Now we're going to talk to you today about the benefits of modernization. And one of the things that I learned early on in my career as an engineer was that technology is great, but you have to be able to tie the technology and the solutions that you're developing to a business problem and have a business benefit. So a lot of the modern applications that we see today have these characteristics where the business benefit could be improving customer experience. So if that's a goal, your modern application will want to scale to millions of users, and not only have to the ability to scale out or scale up, but to scale back down to save on costs. Another business benefit, increasing the efficiency of developers. The modern application will have global availability, right? Being able to have availability in different regions where your customers are located, that's a key aspect of a modern application. And then increasing agility and reducing TCO. Again, modern applications have those characteristics. What does a modern application look like? You're probably all familiar with the diagram on the left. And so this is the traditional, what we call the tightly coupled architecture. And in this architecture, we have a web server for the front end. We usually call this a presentation layer. We have the application servers, which handle all of the business logic. And then underneath all of this is the database itself. And I talk to a lot of customers about databases, and right now this is a single monolithic service. And so whether it's an Oracle database or a SQL server, it's just one giant monolith that has to be managed and controlled. The diagram on the right is where we're seeing a lot of our customers go, and this is the microservices, or what we call the decoupled architecture. And what you notice about this architecture is that you still have your presentation layer, except now we have other sorts of media that we have to be aware of, like mobile that I mentioned earlier before. People still use desktops, and as well as the web. The business logic is a little bit more complicated. We've got things like AWS Lambda. We have Kubernetes services that might be used in the business logic, and then container services as well. And then finally, underneath all of this is the data layer. And the data layer is very different. The data layer is composed of multiple what we call purpose-built databases. And I'll talk a little bit more about what that means. And so in this example, we're using Aurora for maybe transactional data. DynamoDB could be customer reviews for an e-commerce application, and then a graph database for comparing recommendations in the application. So again, developers want the right database to meet the application's unique requirements. When we go out and talk to customers, developers want the freedom. They want to be able to scale their applications easily and scale the database easily as well, and then do this in a very performant way, all while saving on costs. So when we look at that and we sort of took a step back, and instead of looking at the ideal database, in our mind, it's really a combination of a few different databases. At the top, we've got the relational databases, and these are sort of your traditional Oracle or SQL Server databases. But then we have these others, key value databases. We have a service called Dynamo for those. Document databases, which Geeta's going to talk about here in a bit, and then the others as well. And so the sort of key takeaway here is that we have a database that's purpose-built for your particular use case. Again, whether it's a relational service or a key value service like Dynamo, which, by the way, the retail side of Amazon uses for Prime Days, and we just used it for our Cyber Monday deals. We're processing anywhere upwards of hundreds of millions of queries per second, which is very, very unusual scale for that type of database. If you're working with MongoDB and you're looking for a fully managed version of Mongo and you want to save on costs, we have DocumentDB. And again, Geeta and Preston are going to talk more about DocumentDB. If you're looking to front-end your relational services with a cache, that's maybe compatible with Redis, then we have Elasticache that's available. Relationships between data, things like fraud detection, social media. We have a lot of customers that are using Neptune specifically for those purposes. And then if you're dealing with time data that's separated and sequenced by time, we have a service called TimeStream. And we see applications in IoT, in DevOps, and clickstream analytics. In fact, we have a customer that I've been working with that's looking at how users are moving the mouse across the screen and where the mouse is staying, what they're clicking on, where they're pausing, and they can gain insights from these sorts of data. If you're looking to stand up and provision a blockchain, we have an Amazon managed blockchain service. And then finally, if you're working with Cassandra and you're using those types of APIs, Apache Cassandra, we have a service called Keyspaces that can help you there. Again, this is not to confuse you. There's a lot of services here. They're really meant to give you flexibility, to help in terms of performance, and to really match the use case to the particular service, and most importantly, help save on costs. So with that, I'm going to pass it over to Geeta, and she can give you more information about Capital One.
Thank you, Ryan. Wow, the lights are blinding. Hey, everyone. My name is Geeta Gopal. I lead cloud and productivity engineering for the US card line of business at Capital One. So my team manages all the cloud accounts for the card line of business. This is hundreds of cloud accounts that deploy thousands of applications and thousands of cloud resources. This means all of the risk, resiliency, compliance activities that come along with managing cloud accounts, we do. The second part of it, which is the productivity piece of it, the crux of what we do here is really create tools, techniques, technologies, and processes that allow our developers to be enabled to safely and securely develop software. So the motto is really here to supercharge our engineers so that they can then focus on our end customers and create exceptional services for them. So a little bit about Capital One before we go into the topic. Most of you probably know that we are a Fortune 100 company, top 10 US bank. We serve over 100 million customers. One interesting fact about Capital One that some of you may or may not know is that Our CEO is still the founder of the company. Being founder-led has a lot of advantages. Come this January, I'm going to be 16 years in Capital One, and the culture of Capital One is definitely a big part of why I've stuck around in this company for so long. So very early on, in 1994, ever since our first customer and first credit card, the company realized that data and technology can allow even large companies to be nimble and innovative. So about 10 years ago, in 2013, we embarked on a transformational technology transformation journey. Starting in 2013, where we completely shifted to agile software development, to early this year when we launched Capital One software and everything in between. We became open source first. We became cloud first. We completely re-architected our data environment, including the adoption of Snowflake. But perhaps the most important thing that we did in this 10-year journey is completely moving to the cloud. And as of 2020, we are 100% on the cloud with 0 data centers. So AWS is definitely our strategic partner in this. But the most important thing I wanted to tell in this 10-year journey is that we developed a lot of tools and techniques internally that did not exist in the marketplace at that time to be able to scale and thrive on the cloud. An example is Cloud Custodian. We developed our own cloud controls platform. We developed our own internal gateway platform. So I wanted to set that context before we went into the topic. So in the next 40 minutes, we are hoping that we will take you through how Capital One adopted purpose-fit databases to accelerate our innovation. We're then going to tie it to our business use cases. We've picked 3 business use cases for you: DocumentDB, Aurora, and DynamoDB, and Preston is going to cover these. And we will conclude with some migration guidance and best practices that we have learned in the last 2 years of migrating hundreds of workloads across multiple databases. So going back to our cloud journey, we modernized and migrated thousands of workloads. We continue to thrive on the cloud. We use modern development practices. We use all of the innovative cloud services that AWS puts out year after year. We continue to become more and more cloud native. But one thing that we noticed is that our front-end APIs were evolving and modernizing at a much more faster pace than our databases. We saw that several of our APIs were connecting to our monolithic databases in the back end. We all know that in a microservices architecture, if you do not modernize your back end, you do not get all of the agility that you want to get from a microservices architecture. So, but the question is why? Why is it that the back end is not evolving at the same pace as that of the API layer? It turns out database management is a non-trivial activity. Now, databases are the crown jewels of any organization. This is where we store our data, and this is where we protect our customers' data. So anything that we do in this space cannot be done lightly. It does take a lot of expertise and specialized skill and knowledge across the entire data lifecycle to be able to do this really, really well. That starts with the database infrastructure, which is choosing the right purpose-fit database, provisioning the database with the right architecture, the right access patterns, being able to migrate the data to the target store, doing your backups and recovery, and then managing and maintaining the database. And this includes several tasks in itself, which is maintaining and managing resiliency, availability, security, compliance activities, capacity planning, laundry list of things. So we embarked on a journey to really, really simplify database management for our developers. So what we did is summarized on the right. In order to simplify the things on the left, we did the things on the right. First is reduction of variability, or reduction of what we call arbitrary uniqueness. Second is to standardize our access patterns. And finally, to automate our lifecycle tasks. And yes, this is even when we are using AWS managed services. So to go over these one by one, reduction of variability. So we scanned our environment to see what are the business use cases that we have and what are the databases that we need in order to serve our business use cases. At one point in the organization, we had 21 types of databases. Just for SQL, we had Oracle, SQL Server, Postgres, MySQL, vendor-based Postgres, Aurora Postgres, Aurora MySQL, Aurora Global, laundry list, like it sounds like a restaurant menu. So we then thought about, do we really need all of these databases to succeed in our business? And it turns out, no, we really needed 2 databases that can serve 80% of our use cases for SQL. And we did this for all of the other ones. So just standardizing the top 5 databases, Aurora Global, Aurora, Dynamo, Document, and Neptune, really served about 80% of the use cases. And then we have another 20% left. But the last 2 that are stored there are not yet standardized. We use other databases, mostly because AWS has not yet made these global. And I'm saying this because for us, going cloud native is not just for the sake of going cloud native. We use the best in the market at the time to serve our business needs. So moving on to the next one. So we reduced our variability, and we said we create paved paths for these databases. Now, it is not that if somebody wants to use a MySQL database, we don't say not to use it. It's just that it does not have a paved path, and it's going to take away from your team's time if you go that route. So after we reduced variability and created paved paths, we created a database selection tool. The database selection tool basically takes your workload metrics, and it analyzes your workload metrics, and it provides recommendation for the best fit database and the best fit pattern for your database. So there are several key considerations here. The data model. Do you have transactional data or you have historical data? Do you have structured or unstructured data? Data access patterns. This is really about read and write frequency, read and write ratios. The next is query type. Do you have a lot of ad hoc queries, or do you largely have static queries? And we also take several non-functional requirements into consideration. Your resiliency requirements, how fast do you have to fail over? What is your tolerance level for how much data you're able to lose in the event of an issue? And scalability requirements. So our database selection tool today is semi-automated, but we are working on completely automating this. Finally, automation of lifecycle tasks. Now, going to AWS managed services or serverless services massively reduces how much you have to do, but it is not zero. If you do not focus on automating some of the lifecycle tasks, your teams are, again, going to be spending a lot of time doing run-the-engine work. So we've picked like about 5 things that we think are really important to automate. The first one is cross-region auto failover. So in this case, it is important to be able to appropriately recognize a regional failure, differentiate it from a zonal failure, and trigger an alert to your engineering teams so that they can do a one-click auto failover. Now, this is important because a lot of times only the engineering teams and the application owner knows whether or not they want to trigger a failover at a database layer based on what is happening at that moment. They might want to failover at the application layer and then do your database. They may want to failover at the database layer. This is something that we want to put in the hands of the engineer. I'm going to go across to the one that says automate resiliency testing. So what we just spoke about is unplanned outages. But we also have planned failovers. We are a regulated industry. So in Capital One, at least twice a year, we have to prove resiliency and run completely for 7 days in our alternate region. So for teams, what we did is we did what is called hands-free resiliency testing, where we integrate failover in our technology operations center dashboard. That way, our technology operations team can do the failover, while our teams, if they're confident enough, can sleep through this whole process. The next one is automated governance. Once you provision a database, there are lots of different governance pieces that you have to take care of, especially in the security and compliance space. Is everything encrypted? Is everything tokenized? But the one thing that I wanted to bring to your attention that you don't want it to be an afterthought is access provisioning. If you do not integrate access provisioning into your access provisioning system quickly, you're going to be spending a lot of time manually provisioning and creating entitlements. The next one is version upgrade. Now, AWS does do auto upgrades of minor versions, but if teams have critical applications, they generally don't want to leave this to auto upgrades because of the unknowns, and they want to do their own upgrades, and also for major version upgrades. So we will talk about DMS towards the end, but we've automated this entire process using DMS, and we've built some surrounds around that so that teams can take the version upgrades in their own hands and in an automated way upgrade in a time that works for them. And finally, monitoring setup and metrics. Now, we have hundreds of databases in the company, and there is no need for every team to set up monitoring and metrics on their own. So we have a basic set of monitoring and basic set of standard metrics that we set up at the time of provisioning and create dashboards at the time of provisioning. So we have a common basic set of metrics, and then teams can build on top of this. So I'm happy to say that because of the decisions that we made and because of the automation that made this journey easy for our developers, we have converged 90% of our workloads to purpose-fit databases. With that, I'm going to hand over to Preston to talk about the business use cases.
Hello, I want to introduce myself. I'm Preston Burrows, Senior Director of Database and Software Engineering in our Enterprise Data Technology line of business, I'm sorry. This light is killing me. So I'm going to start off with DocumentDB. So we're going to start talking about the business use case for our credit decisioning software that we're building. So there's a need for near real-time product credit decisioning. This is really key for us because as we start for our customers, we want to make sure that we're not making them wait for any time to be able to make these credit decisions. So the data is coming from several external data sources to form user profiles. And those user profiles can vary. So we just want to make sure we have the right data within those user profiles. The data structure for these user profiles vary to result into large documents. So that's another key piece that I'm going to talk about when we get to the requirements. And then the user profiles are converted to features, and they're fed for decisioning through a decisioning process. So that can be via machine learning models, fraud decisions, different things like that. It is critical for us, though. This is really important for us. It's critical to achieve millisecond read-write latencies for making proper decisions. Again, we're taking our customers into account, so we want to make sure that we're making those decisions as fast as possible. And then, as I mentioned before about our requirements, I'm going to call out a few key things that I want to talk about. Support large documents, millisecond read and write latencies. The application is in our database, and it's in with our VPC. So again, from a security standpoint, we want to make sure that we're being as secure as possible. So that being in our VPC is very important. And then, as Geetha mentioned before, we have requirements for cross-region auto failover capabilities. And then also, we want to look at for it to be MongoDB compatible. So that decreases the amount of time that our developers have to worry about when we're trying to move from MongoDB to DocumentDB. So it just helps our developers from a timing standpoint. And then the other thing is, again, this is to double down on that document size. Storage growth to 128 terabytes. So we have to be able to have that scalability to get to those large documents. Amazon DocumentDB met most of our needs. So it's a fully managed database. It's scalable, meaning that it can scale with those document sizes. And it's also MongoDB API compatible. So again, what we talked about, letting our developers be able to focus on other things and not having to worry about trying to rewrite the application. So here I want to talk about are built for cloud architecture. So the key here is how the compute and the storage are separate. And the storage and also the compute is scalable. So that's very key for what we need. So here we want to talk about global clusters. This is something that will benefit us in the long run. So first I want to talk about the DocumentDB global clusters, which allows to replicate data up to 5 secondary regions. So that's really good there because it's not keeping us, we have this resiliency scenario, and then we also have a scenario where we are able to, in downtime instances, we can build on that, we can fail over in the right amount of time, so it's very important for us. The replication is offloaded to the storage layer. So this is physical replication from the storage layer in a layer to primary storage layer and a secondary. So again, this is something that will help us from a typical for a less than 1 second failover scenario. And then also the recovery time. It's a global cluster which allows for quick recovery in case of a regional outage. Again, I know a lot of you are thinking regional outage, but it can happen. So we want to make sure that we're thinking about this and that we're planning for it. And then also, you look at the versioning. You have to be at version 4.0 or later in order to be able to take advantage of global clusters. So if you're at 3.6, you're going to have to upgrade. So just want to make sure that that's a call out there. And then if we look at the picture if you look at the diagram, you'll see that if you deploy clusters, global clusters will be compatible. I'm sorry, I'm losing my train of thought. Sorry, let me backtrack a little bit. So looking at the primary, we're in app 1, we're writing to the primary region, and then in app 2, it can read from the secondary region. So that's the key there. You write to the primary with app 1, and then app 2 can read to the secondary. What we did to achieve this. So we had a nearly 2-month intense DocumentDB engagement with Amazon, and it started with an immersion day. So within those immersion days, we had an introduction to DocumentDB, making sure our engineers understood what DocumentDB was. We talked about DocumentDB best practices. We talked about how we can migrate from MongoDB to DocumentDB, what the pros and cons of each one of those different approaches would be. And also, we talked about 2 POCs that were created. The first POCs was to address large reads and writes, and the second POC was for inserting large amounts of data. At the end of the day, coming out of this engagement, we made the decision of what Capital One would be creating or developing and what we would be waiting for or what was put onto Amazon's roadmap. And we're still working with Amazon to help prioritize that roadmap. What I want to talk about here is that during that time when we talked about the roadmap, in the short term, we created some things to fill in the gaps until those roadmap items are available. So the storage compression, which is a need to store documents beyond a year, that right there was something that we created within S3. And then the long-term solution would be a sharding solution, which Amazon just announced yesterday, which was the DocumentDB Elastic cluster. So that's going to help us out. So that announcement yesterday was really key for us. And then also we're talking about downtime for upgrades as well. So we want to be able to address anytime we have to do upgrades that we're going to minimize the amount of downtime to little to no time. So that way our users will not be impacted from these upgrades. And then the other thing is the failover capability. So in the interim, we're utilizing some CLIs and SDKs in order to create a failover mechanism for us. So now let me talk about Aurora Global Database. Again, this is a business use case, which is our customer transactions. We're tracking customer transactions, which again, our customers are very key to us. So we want to make sure that we're able to allow them to track purchases, reversals, rewards, payments, et cetera. We were utilizing a third-party Postgres database to do this, and that was provisioned on EC2. And as Geetha mentioned earlier, we're trying to move more towards managed services. So this was an opportunity for us to move towards a managed service, and that's where Aurora Global comes into play. And again, because of internal requirements that Capital One has for those EC2 instances, there was a lot of time spent on database maintenance in order to making sure that we were compliant with Capital One requirements. We were able to migrate this transaction database to Aurora using DMS, which is Amazon's data migration services. We developed best practices for relational databases, and we also were able to automate lifecycle tasks, including developing a regional failover. Again, as part of our requirements that Geetha mentioned earlier, that out-of-region scenario is key for Capital One. The next business use case that I want to talk about is our payments use case. Our payments orchestration service, it interacts externally with a vendor service. So because of that interaction with that vendor service, there's strict timeout configurations that are needed. And then we needed to have a transactional data store to achieve 4-second SLA during the system issues. So if there was any downtime, we could not afford to have anything more than 4 seconds. So this is very, very important here. In order to address that 4-second requirement, we created again, Capital One, we're going out there and finding new ways and things to do things until AWS has that available for us. So we created put a caching layer, a Redis caching layer in front of the data layer, which allowed us to be able to meet that. So in the event of a database failure or database regional outage, the data layer would go down, but this caching layer would serve for our users. So this was really, really key here. So again, using our ingenuity, able to address this and address this failover. Again, this is what we do at Capital One. Now we'll talk about DynamoDB. So the use case here was a need for a low latency data store. So when I talk about low latency data store, we need a near real-time fraud decisioning tool that would allow our reps to be able to handle any type of fraud that comes up in a very close to real-time scenario. So we were able to use some tooling that we already have within the company, but we also needed to have a near real-time database option that would address what we needed as well. So this use case right here, as I just mentioned, was the fraud. The app should retrieve that data very quickly enough for our fraud servicing agents to be able to investigate fraud in a timely manner. So you'll see here as we go through here, when I talked about what we had in-house already, which was a data streaming layer that we built internally, we took advantage of that data streaming layer and then put DynamoDB in the middle of that. So it comes through that data streaming layer, gets put into DynamoDB, and then an API was created in order to pull the data out of that DynamoDB instance and then serve it up to our fraud agents. So this again, ways that we've gone around and made things to where it's serviceable for us. So this particular here, you're probably saying, wow, this looks very familiar. Well, the thing that I want to call out here is that how we use the same architecture on multiple use cases, and it shows our commitment to standardizing. So that was the big thing, and that's where this particular slide came into play, and most people were like, it's the same slide. But as you can see, it's a different use case. So again, I just wanted to call that out. And now I'll turn it back over to Geetha for our data migration services. Thanks.
Thank you, Preston. So Preston talked about a lot of different business use cases. Fraud, credit decisioning, where we have to provide a decision to our end customers in near real time. We talked about our payment use case, where we are dependent on a vendor. There is a 4-second SLA. Once a payment transaction comes to us, if that payment transaction fails, then there's a lot of post-processing that we have to do. So we had to front it with the cache layer so that the cache layer can serve as the database layer is taking its time, about 2 minutes, to fail over to the alternate data store. So with the cache layer, our app on the west side is able to continue to write to the cache layer, read from the cache layer, and then when the database is up in about 2 minutes, you can flush it all back to the database. We talked a little bit about our, what was the other use case? Payments, not coming to my mind, forget it. So all of these use cases, we had to migrate data. We have to migrate data from one type of database engine to another type of database engine. So there are multiple use cases for massive data movements within Capital One. And many of these use cases are a good candidate for AWS database migration service. But the thing to remember about AWS database migration service is that it has limitations, and it also requires us to meet some prerequisites. And what this does is it prevents our developers from safely and efficiently using DMS. So what we did is we developed an internal database migrator service on top of DMS that takes care of these things for our developers. Now, the Migrator tool is integrated into Capital One tooling. It is part of our CI/CD pipelines. And the DB Migrator tool will evolve as we continue to work with AWS and influence their roadmap for DMS. So a little bit more about our database migrator service. What the diagram is showing there is that the database migrator will scan our source database. It figures out all of the prerequisites that are needed, and then it creates the necessary resources using DMS, and then it migrates the data, and finally, it helps our developers clean up all of the data. So I'm going to go a little bit more into the details in the next slide. So what is it that the database migrator does above and beyond DMS? So I will start with, this is not only about DMS limitations, but it also helps us integrate into the Capital One ecosystem. For example, the DB Migrator is, like I said, part of our CI/CD pipeline, but we also integrate it with, for example, our internal vault to go get the credentials that are necessary for the setup process. We integrate it with our internal artifactory system to go download the necessary artifacts. The second set of things the DB Migrator does over and above DMS is it scans the source database, finds out all the prerequisites, and tells the developer if any of the prerequisites are not met. For example, if a table does not have a primary key, it'll let the developer know so they're not failing at a later stage during the migration process. The second thing it does is, once it scans the source database, it finds out its volume, access patterns, etc., and it creates the necessary DMS resources automatically. It sizes the DMS resources, sizes the replication instance, and tunes it for the developer. So we take the guesswork out of it, and this is all done for the developer automatically. The third thing the DB Migrator does is, DMS does not migrate a lot of things that are not necessary for the data migration process. For example, it does not migrate all the schema objects. It does not take into consideration foreign key constraints. So our DB Migrator does all of this, It migrates schema objects, for example, all the secondary indexes, your views, your procedures, functions, data defaults, migrates all of these things. It also enables foreign key constraints, not on the full load, but on the change set. It enables foreign key constraints. And it also, we also extend the validation process so that not only can the developer validate the data after the full migration, but they can actually validate the data migrations throughout the entire migration process. We also have extended the logging so that we have a better view of end-to-end migrations, again, throughout the process. And finally, DB Migrator cleans up all of the, once the cutover is done, it cleans up all of the DMS resources for the developer. So these are the things we do above and beyond what DMS does. And we worked very closely with AWS to determine where we don't blindly go invest in developing these surrounds. We work very closely with AWS to understand what their roadmap is, how far away they are from developing the capabilities that we need, and where we find that it is useful for us to use MVP service of AWS, we then go and invest, because instead of letting hundreds of our teams migrate manually or use a DMS service and reinvent the wheel, find out all of these things that I'm talking about, there is return on investment for us to go build some of these surrounds so that we can make it easy for our developers. So that's the way we think about investment. So the success story for us in moving to purpose-built databases lies in our two very important partnerships. The first one is with our engineering teams. The second one is with AWS. With our engineering teams, very critical, because we are not sitting in a closet and figuring out what are the databases that are needed for our engineering teams. We work very closely with our engineering teams. We try to understand our business use cases, and then in close partnership with our engineers, we figure out what are the right purpose-fit databases for which we have to create paved paths. What are the tools, techniques that we need to invest in, and what is the time frame that we need to invest in these so that we get the return on investment for all of the investment that we're putting in. The next partnership is with AWS. Like I said, we do use MVP services of AWS. This is a pretty big debate that we used to have often about, should we really be building all of these tooling on top of AWS? It doesn't make sense all the time, but if you think about it, and if there is return on investment, and if you are able to use that MVP service to gain speed to market, and if it makes sense for your business growth, I think for us it was a yes. So that partnership with AWS was, again, very critical to achieve this. So that is our success story in moving to purpose-built databases that is powering our innovation. Thank you all.